Hello, my name is Jonah Jolly. I'm a staff engineer here at Devitry. This quick video is a complement to an article we released about the work we did ensuring compliance in a C++ codebase utilizing Clang LibASTMatchers. If you haven't checked out that article, you can find it on our website. I hope to give a quick overview and demo to help you get started working with this tooling and show that it is relatively straightforward. There's a lot of depth with these tools, but this is a good starting off point. A quick overview of the Clang AST so that we're working with the same vocabulary. AST is abstract syntax tree, and it's created with the Clang front end. It provides an AST context class, which holds a source manager and identifier table, and this supports the AST nodes being created, as these nodes will reference into it for things like source code location. There's three core classes that we care about. Decl, or declaration, think variable declaration or function declaration. Statement, so think if statements or switch statements, and types. These classes don't share a common base class between them, which is important to note because that means there isn't a way to traverse nodes from nodes. To do so, we need to rely on LibASTMatcher, which is a DSL that provides a way to express predicates to match on the code. When we create a predicate and match on it, in a standalone tool we can use a match callback to get a reference to the context that we want, and then we can apply whatever logic we want at that code location. The three categories of matchers that we really care about are node matchers. These are the main nodes that we match on. They're higher level, and this is the point where we create bindings on that can be used in a callback. Think like variable declaration or an if statement here, or method declaration. The next matcher is a narrowing matcher. So if we matched on a variable declaration, we don't want every single variable declaration in the code base, so we do want to use a narrowing matcher such as has type, has parent, or is derived from to be able to key in on the exact node that we want. Finally, because we can't move up and down the tree from a node that we get, we use traversal matches for this. In a moment, we'll see an example of the AST, and in there, it's a tree-like structure. And so if we wanted to walk up the tree, we could use something like has ancestor. And if you wanted to go farther down into the tree, you would use has descendant to go down. Another more complicated example of traversal matcher would be in a constructor, you have an initialization list, and you want to iterate through all the fields being declared. So with this, let's write a basic matcher. So the problem that we want to solve is that we have this monitor here, and it has an alarm client that takes an alarm as a string, and when we call its raise function, it dispatches an event off to the system that gets handled. We want to ensure every alarm client has its raise called, and we want to know what the alarm name was so we can do further checking. So to get started, we have our monitor here, and we can see we have this variable declaration of spooky factory alarm client. And alarm client is instantiated with the alarm name sugar too hot. And then down here, with mythical logic, we finally raise it. So the first thing that you want to do when you're writing a new matcher is you want to look at the AST that we're going to be matching on. So to do that, you can do what's called AST dump. And so you say xclang AST dump and then syntax only, and you call it on the file that you want to use. And so here we get a whole dump of the front end AST. And so what we care about here right now is we can see we have this variable declaration of alarm client. And what you can also note is if you see right afterwards, we have the address and then we have like line numbers, and this is coming from that AST context. Further down, we have a string literal here, sugar too hot, and so that's what it's being instantiated with. And if we think back to the traversal methods, you can say variable declaration has a descendant of string literal, And it also has an ancestor of a method declaration. So inside the run function declaration, we have this variable declaration. So with that, we can go to Clang query and try and write a matcher for this. Clang query is a really cool tool. It allows for interactive exploration of the Clang AST using AST matchers, and it allows writing matchers in an interactive prompt. And what we can do is just copy that matcher after we are satisfied with it and put it in the standalone tool with no further movement. So we'll run Clang query on sugar too hot. And so now we're in Clang query. The first thing that I always do is I set bind root to false. If you don't do this, you'll get a lot of extra noise. And we really just want to focus on the intentional matchers that we're creating. So you can say match and a matching statement, or M for short, and you can say var decal. And you'll see we get four different matches, but we really only care about one. And so if we were to bind this so that we can see what it's getting matched on, we could see there's a bunch of different statements that apply to a variable declaration. But we only care about this sugar too hot one, right? So to do that, we need to use what's called a narrowing matcher. And the narrowing matcher we're going to use is has type. And then has type, you need to further clarify as string. And one cool thing about Clang query is that you can autocomplete. So autocomplete there, and we say spooky factory alarm client is the type. And now we're only getting the alarm client match that we want. So the next step here is we have the full declaration statement, but we also need to get what it's instantiated with. And if we were to just take this matcher that we have and put it in the standalone tool, we wouldn't be able to reach that instantiated string literal. So what we need to do is we need to add another matcher inside. Inside of a node matcher, it's as many arguments as you want, and it's treated as an all of statement. So every single statement that matcher that we write inside has to be true. So in here, since we're going down the tree, if we remember what that AST tree looked like, it was a descendant. So we say has descendant, and we can just say string literal. And then we want to bind that on like string literal, let's say. And then you gotta make sure that you close your parens correctly. So now this is awesome. We can now say alarm client, and then we can grab the string literal. And so we could do logic inside of our callback to say an alarm name of alarm client, and the alarm name was sugar too hot. And then we could find its raise call and correlate them. But what if, for instance, we had multiple functions in this monitor, and each function used a local variable called alarm client? We don't have a way to fully qualify what alarm client we're looking at. And so to add that piece of information to the work that we're doing, we're going to add one more matcher. And so we have a has descendant because we went down into the instantiation. And now we have to do a has ancestor to walk back up to find what method we're inside. And to do that, you can use cxx method cxx c. Am I in the right one? Sorry, you can do we first need has ancestor, and then we say cxx method decal. All right, and then we can bind that to method. And now we see we have all three pieces of information that we need. We have the instantiation, we have the function that it's under, and we have the variable that it was declared with. So with this information, we can go and put it in a matcher. I have a matcher here, all written up, and most of this is all the boilerplate from the Clang documentation. It really helps you get started. There's not a whole lot of changes that you need to do to make it production ready. And just quick overview of what I've added. I've added this little instantiation result type, and then we're just printing out some JSON. And the idea is that we print this JSON out to standard out, and then we would have a post-processing tool that could read in these events and correlate them. And this is important because, let's say, the variable that the alarm client was declared with was from a config file. We could then have extra logic to go find that config file value. And then in here, we have this config argument, and we grab the string literal, and then we write it out. And then this is the alarm matcher that we were practicing with in the Clang query is just a copy paste, which is really cool. And then we write this matcher, this callback, and inside we pull out the different nodes that we bounded to. So we have the variable declaration, we have the method declaration, and then in here we have the string literal, and we just get the name and the qualified name, and we put it all together. And then here's more boilerplate that the documentation gave us. And then right here, we can do the handler, and then we just bind it into the match finder, and we add the matcher. And so with that, compiled with the Clang tooling, we can run it on the Sugar2 hot monitor, and we see that it found everything for us. We found the alarm client instantiated name with Sugar2 hot monitor run alarm client, and if we have like a different function name, run2, we'd have that as well. And then it was instantiated with a string literal of type Sugar2 hot. So this was a basic overview of how to kind of get started. This was a pretty pointed example, but I think it gives the basics on how to navigate the Clang AST and the matchers to find what you want in your code.